Hi, I'm going to be walking you through a demo of Spectrum Protect and Spectrum Copy Data Management. And I'll be doing this from the perspective of different users who would be interfacing with Spectrum Protect and CDM. Spectrum Protect was designed around user experiences, and we did lots of research into what typical data protection admins, VMware admins, database admins, and end users required and expected when utilizing Spectrum Protect. So I'll be introducing you to Brad, who's our data protection architect, Bob, who's a DB admin for SQL, Kevin, who's our VMware admin, myself, who will show you the perspective from an end user, and Stacy, who is a storage admin. So let's start from the perspective of Brad. Brad would be our Spectrum Protect architect. When he logs on in the morning, he's going to log on to the single pane of glass web interface that we call our Operations Center. The Operations Center aggregates multiple Spectrum Protect servers' data into a single pane of glass. This allows Brad to monitor, troubleshoot, and expand the Spectrum Protect environment all from a single location. So I want to take a few minutes here to explain what he would be looking at in the morning, not only because that gives us a good idea of how the Spectrum Protect is laid out, but it also shows us the different aspects of the monitoring as well as the wizards that we have built into the Operations Center and what his daily task would look like. Here on the top row, we have our Spectrum Protect clients. These are the machines whose data we are protecting. So these are the customers' production machines who contain vital information that they want to have either backed up, archived, or space managed on a daily basis. Below that, we have the services. And the services talk about what type of protection Spectrum Protect can offer. You see we have backup, we have archive, and we have migration. And I'll be talking about each of those in detail. Finally, we have where we are actually storing and managing the data that we're protecting. And this is called our Spectrum Protect server. And it's kind of the workhorse and the brains of the entire backup and data protection operation. So let's look at the stratification that goes with this general environment here. First of all, we have our clients. And when Brad logs on in the morning, he's going to be taking a look at this at-risk ring, because this at-risk ring is immediately going to point to him if there's been any type of problem backing up or protecting the data that's residing on the machines we're hoping to protect. And he sees right away that we have something at risk, so some type of data protection didn't occur. And then we can see that something's currently kicked off, so we have some type of active process right now running in between the Spectrum Protect clients and Spectrum Protect server. And then we see the rest of the data protection was normal. Now here you can see we have 55 clients. So this is just a small test environment that we're showing you. In reality, our users would have thousands of machines that they're protecting. And these machines break down into different types of machines. We have application machines, and these would be the user's databases, their SQL databases, their SAP HANA databases, their Exchange databases. We then have virtual machines. These would be like the Vmware or the Hyper-V machines that we're protecting. And finally, we have the system machines. These would include file servers, NAS machines, API clients, or perhaps just regular old desktops. So when we take a look at these risk factors here, we can see immediately that one of our application machines had some type of fault. And when we look at the systems, we can see two of those for some reason didn't back up. Now, in this scenario here, this is a mock-up. We've made some things fail so we can show you the different features. But in a normal customer environment, we would expect the backups to occur on a regular basis and be occurring without any problem. So we've put these in here so we can show you how easy it is, if there is a problem, how rapidly Brad can do the troubleshooting. Now down in services, we can take the data that resided on those production machines and do a couple of different things with them. The first is our backup. And when we talk about backup, we're talking about protecting files in case that file got damaged in case that production machine had a hardware failure, in case there was a virus attack, and they need to bring back the data to either how it looked last night, or maybe even how it looked multiple versions ago, last week, or further back than that even. So backup is about protecting the data so we can restore different versions to different point in times. The next type of service we can provide is archive. An archive is all about keeping the data for a specific amount of time. And this usually has to do with regulatory requirements or government requirements. So think about tax records. In the US, we have to keep taxes around for 7 years. So we would want to archive off our tax records so that they were being retained for 7 years. And then the final type of service is migrate. And migrate takes the files that are sitting on a production machine and it moves them to cheaper disk or cheaper storage that's underneath the Spectrum Protect machine. So many operations, whether they're hospitals who have to keep lots of x-rays, whether they are oil companies who have all kinds of geological surveys, whether they're production companies with lots of blueprints, whether they're media companies with lots of movies or music files, they want to have those files easily accessible right on the production machine. But that type of storage is pretty expensive. So what we do is we take those files and we migrate them out to the Spectrum Protect server. We replace them with just a little placeholder, a little stub file. So if the end user or the end application goes looking for those files, it looks like they're still on the production machine. But in reality, they've been moved off to cheaper storage and are being managed by Spectrum Protect. Now, if the user tries to access that, does any type of I/O against that little stub file, those files are immediately brought back to their original location and the end user has access to them. So the end user probably didn't even realize they had been moved off. So this is a great way to save money by not having a whole bunch of very large files sitting on expensive primary disk. Now, each of these services can be utilized by all of our different types of machines that we have out there, and we can set up policies to determine who's using what, and for instance, how many versions of the files do we want to keep, for how long. All of that is determined by policies. And these policies can easily be customized to meet corporations' needs and the individual user's needs. So you may have just a few policies in an organization, or you may have many. Another thing that the policies will determine is where the data is being stored out on the Spectrum Protect server. And it'll also determine when that data needs to be expired off the Spectrum Protect server, when we no longer need to keep that many versions of the file, or when that archive file, that tax file, has hit 7 years in 1 day, we can expire off the older versions. The next thing that Brad is going to take a look at when he comes in is these alerts. Now, these alerts have to do with giving him a proactive way of determining what's going on inside of the environment. Because when we look at this backup environment, not only do we have to deal with issues that might have arisen on the production machines, maybe there was some type of hardware failure, maybe it was powered off and the backups didn't occur, but also on the network, maybe there was a network failure, or maybe even on the storage where we're going to store it, maybe there was a tape failure. So these alerts give Brad insight into, hey, something happened in this whole production environment and I need to take a look at that so that this data protection system is kept up and running. The next thing Brad's going to look at on this screen is the activity. And this is the activity over the last 24 hours on all of the different things that were going on inside of the Spectrum Protect server, whether it was backups that were occurring, whether a customer had to recall some files, whether we did some node replication for disaster recovery purposes. We can see how much data was going in and out. And this is a great way for Brad to compare it to what happened 24 hours ago, and that's the dotted line beneath, to understand if there were any peaks. For instance, maybe there was a need to restore an entire machine, and so we had a big peak in data I/O. Or perhaps a new machine was added into the workload to be backed up, and that has added additional overhead. And therefore, Brad might want to take into consideration that and what that means to his operations. So this is just a good way to see if it's looking like we're doing about the same activity as 24 hours ago, or if something's changed that we want to take a look at. And of course, those can also be broken down into the specific type of machines that were doing their backups, whether they were virtual machines or system machines or application machines. And that gives Brad an easy way to kind of narrow down where did the additional activity occur. Next, Brad's going to take a look at the Spectrum Protect servers and make sure they're all up and running. Now, as you can see, here we only have 2 Spectrum Protect servers for this environment. Some of our customers, they may have many Spectrum Protect servers, and that has to do with the geographic location of where their Spectrum Protect servers might be sitting, if they have different IT centers across the US or wherever. The nice thing about the Operations Center is that we do roll up all of the information for these different servers into one single pane of glass, and then if needed, we can dive down into the individual server or the individual Spectrum Protect client to get individualized information. So this stratification, it gives Brad a big picture, but also the ability to dive down and get details. So we can see our 2 Spectrum Protect servers are up and running. And we can see that the database and log that sits underneath the Spectrum Protect server has space to continue growing. And the database and log are important because that's where we keep all of the information about what is being backed up, who owns it, how long we keep it. It's our metadata catalog. And it's the brains of Spectrum Protect that really empowers us to do a lot of the cost-saving functions, whether that's inline dedupe, whether that's incremental forever, whether that's migrating data from one type of storage to another. All of that we can do because we are empowered by being able to track the individual information about all the different files we're protecting. And so, of course, Brad has checked to make sure that there's enough space on the database and logs so that as new backups or archives come in, we can continue to accommodate them. Finally, we have our storage and data availability. This is where we are storing the data once the clients send it to us. This can consist of all types of different technology. There might be disk, there might be VTL, it might be tape, and it might be cloud. And so when Brad looks at this overview, he's able to see for these different storage pools how much free space is out there. And of course, if it's a cloud, we consider it to have infinite free space. He can see if there's any warnings or errors that he might want to take a look at. In this case, this disk storage pool is getting a little full. He can see the copy storage pools we have out there. And if you had tape, in this case we don't, but if you had tape, that too would show up how much availability and if there were any errors showing up. So the storage is important because it is where we're storing the data at that we're protecting on the clients. And then finally, Brad will take a look at replication. And replication is how we do disaster recovery for the Spectrum Protect servers. So if for some reason one of the Spectrum Protect servers goes down due to a hardware error or maybe it goes offline because of a natural disaster, we want to have that Spectrum Protect server available, all of that data available on another Spectrum Protect server so the clients can still access their backups and can still do their restores and can continue to be protected. So replication is our active-to-active disaster recovery solution. And here we are just taking a look at how much is still being replicated throughout the day. Okay, so in summary, when Brad comes in the morning, sits down with his cup of coffee, he's going to log on to this web page and take a look at the Spectrum Protect environment and kind of figure out, what do I need to pay attention to today? Were there any machines that were not protected from our Spectrum Protect clients? Are there any alerts that I need to pay attention to in the environment? And do I still have capacity on my Spectrum Protect server, both for the metadata as well as where the actual data resides? The Operations Center can handle multiple Spectrum Protect servers and can basically roll all that information up into one single pane of glass. So let's go ahead and dive down and take a look at some more of the details. And we're going to start with the Spectrum Protect servers. Here you can see we have 2 Spectrum Protect servers defined, the TAP server 01 and the TAP server 04. We're going to primarily be looking at the TAP server 04. We can see that there's 50 clients associated with it. And if you remember on the first overview screen, we had a total of 55 showing up. So 50 belong to TAP Server 4 and 5 belong to TAP Server 1. We can see if there's any alerts that are specific to this server that Brad will want to pay attention to. And we can see how much data space is available here. Also how much log space is also available. We can see when the last database backup occurred, and this is important because the database backup gives us a way to take off-site a copy of our Spectrum Protect database. So if there is any type of failure on our primary server and we need to rebuild it, we have a copy of our database. We can see the last time it was rebooted, and we can see what type of data is being managed here, whether it's backup, archive, or migration data. When Brad went about setting up these two Spectrum Protect servers, he would have utilized our blueprints. Now, our blueprints are online. Anybody can access them out there. And what they do is the blueprints provide a prescriptive step-by-step process for designing, sizing, installing. It provides scripts to actually get the installation automated. It provides best practices, which will lay out, for instance, schedules and policies, as well as prepare for replication between the two servers. And it'll also help prescribe specific hardware so that Brad knows, if I'm building this Spectrum Protect server, what type of memory should I use? What type of disk? And then it'll actually go out there, these blueprint scripts will go out there and actually test the disk, for instance, to make sure it does have high enough performance to support the Spectrum Protect databases and logs. These Spectrum Protect blueprints really help to provide that prescriptive guidance on sizing and hardware and setup. And it expedites the whole installation of that Spectrum Protect server and makes it simple for either the customer, Brad, or a business partner or an IBMer to get those IBM Spectrum Protect servers installed in a fashion that will be effective for the customer. The blueprints do come in small, medium, and large sizing. And this has to do with the overall amount of data they'll be protecting and the daily workload. So our TAP Server 04 is a medium Windows server, and it can handle up to 880 terabytes of data, which is about 20 terabytes per day. Whereas the other server is a large Linux server that can handle up to 4 petabytes of data with a workload of 100 terabytes per day. These were set up as a replication pair. Even though both of these servers protect their own clients, TAP Server 01 will act as a target server also for TAP Server 04. So not only is TAP Server 01 protecting its own subset of clients, it will also be the replication target for TAP Server 04. When we have these servers set up, the next thing, one of the other things that the blueprints have laid out are the client schedules. Now remember, when we do the backup of the Spectrum Protect clients, we have different types of data that we're protecting. And if you remember from the overview page, we had our application servers, we had our file servers, and we had our virtual machines. And each of those data is a bit different. And so the schedules that get laid out by the blueprints are going to address the specific backup needs of those types of machines. So let's take, for instance, right off the top, we see a Domino. So this would be a Domino database. We also see an Exchange schedule. And down here, we also see, for instance, Oracle. And I'm sure there'd be an SAP HANA as well in here. So when we're backing up database or mail files, we are working in conjunction with that database or mail vendor to utilize their prescribed backup methodology. For instance, Domino will have an interface that Spectrum Protect will work with, and they will have said you will do full backups plus differentials. And then perhaps there's also transaction log backups. So each of the database vendors will have specific ways that they want their database protected so that we get an online persistent backup of that database that when we go to restore it, it'll offer things depending upon the database vendor, perhaps individual file restores, individual mailbox restores, and things like that. So these schedules will have already set out the interface with that database backup vendor's API to correctly back up the different applications. The next type of backup we see here has to do with the flat files. So this would be your file servers, this would be your workstation, this would be your NAS boxes. When we do flat file backup, Spectrum Protect does something called incremental forever. Incremental forever only backs up new or changed files. We never have to do a full backup with dependent differentials or incrementals. And we never have to do a synthetic backup where we're taking up a whole bunch of processing, refiguring data to make it look like a full. We only back up new or changed files. I often give the example of when you wash your clothes. It only makes sense to wash the clothes that are dirty. Why in the world would you want to go through your closet and wash all of your clothes, including your wedding dress and your winter ski pants that you haven't worn in 3 years? That's what a full backup makes you do. That's what other backup vendors make you do. And that is not only wasteful because it takes up a lot more network and a lot more processing time, but it takes up a lot more storage on the data protection server. With Spectrum Protect, we don't have to do that. We only back up new or changed files, and we track those in our database, the metadata catalog. So when it comes time to restore, that metadata catalog of ours is able to just bring back and tell you which files to restore. So the restore is also more efficient because we're only bringing back the version of the file you need. We don't have to bring back a full and then lay the incrementals or differentials on top of it. So Spectrum Protect's incremental forever is extremely efficient and is going to save the database and the whole Spectrum Protect environment a lot of space, a lot of networking, a lot of processing, and makes it a more efficient solution. And that means we don't need as many backup servers in an environment to protect the same size environment as our competitors would. Once again, because of our efficient metadata catalog and the way that we're laid out, this incremental forever saves the customer networking, time, space on their storage, and processing. In addition to the flat files, we backed up virtual machines. And so with the virtual machines, we would also have schedules that would be specific to working with VMware. For instance, with the VMware backups, we'll utilize the VMware snapshot capability with change block tracking, and then we'll just incrementally back up the changes that the change block tracking shows. Our VMware backups, once again, are different than our flat file backups, which are different from our database backups, and that has to do with we're protecting the different types of data in the methodology that those data vendors have asked us to. If we take a look at this incremental schedule here, when it was laid out, you'll see that there are specific details. What time the schedule kicks off at, you can see it starts at 10 o'clock here, and which policy it's associated with. We also see the clients here that are actually using this schedule. We can see these particular clients are taking advantage of the incremental forever schedule. In summary, the schedules are laid out by the blueprints using best practices. They address the different types of data we need to protect and the different ways that data needs to be protected, whether it's your databases, whether it's your flat files, or whether it's your virtual machines. These, by default, will kick off on a nightly basis at a specific time, but Brad, our administrator, could easily go in there and schedule them to kick off at different times or have slightly different repeat dates and things like that. So we can customize those as well. Let's take a look next at the storage pools, and that's where the data is going to be backed up to. We use policies to link the schedules with where the actual data is going to be stored. And the policies are also laid out by our blueprints, and they're going to specify specific things like how many versions to keep of the backup, how long to keep the archives, and where to store the data. And that becomes really important because when we back up data, Spectrum Protect has a whole system of hierarchy of storage. And depending upon what the customer has in their environment, they may want to do a disk-to-disk backup, or they might want to do a disk directly over LAN-free out to tape. Or they might want backing up their disk files to another disk storage pool and then have that automatically migrate out to tape after a specific amount of time. And Spectrum Protect has the ability to offer the flexibility to meet the customer's needs. We support thousands of different types of disk and tape and VTL, and those can be defined to meet the customer's needs. When the blueprint carves this out, it will initially carve out a disk container storage pool. And so you can see right here, directory container pool right here would have been carved out by our blueprints for the TAP 1 and the TAP 4 server. And it would have been sized according to whether it was a small, medium, or large implementation. Let's take a look at what we're seeing here on this screen and what Brad's able to ascertain just by this overview. First of all, he's going to see the type of storage that we're looking at. Now remember, we can do tape, we can do disk, and we can do any type of combination you want. So when the customer sets this up, they're going to say, okay, I have this very large SAP HANA database that I want to back up directly out to tape. So they would define their tape, they would set up LAN-free, and we could then do the backups directly to tape. Or maybe they say, I have this primary pool here, I'm backing disk to disk, but then I want to create a copy of it out to tape. And that copy will then be taken off-site so that if there is some type of virus or whatever, I have an air gap, and that copy is safely over in Iron Mountain. Now the nice thing about using tape is not only can we back up directly to it, we can also use it as a secondary copy location. Once we write the data to the tapes, we can then track those tapes when they are taken off-site. So we know, for instance, that they've been ejected from the library. And we know when, for instance, they've been taken and given to the FedEx person, and when they've been arrived at the Iron Mountain, and which vault they've been put into at the Iron Mountain. So that if there is a disaster and Brad needs to get those tapes back rapidly, he can easily ascertain where they're at. Spectrum Protect also manages those tapes to utilize their capacity to the highest efficiency. When you write out to tape, you start at the beginning and you write to the end. But remember, over time, Spectrum Protect will be expiring data because we no longer need to keep that data. It was tax files that we no longer need to keep, or perhaps it was backup versions we no longer need to keep. So you end up with a whole bunch of dead space out on those tapes. Well, some other competitors will simply just leave those tapes there until everything's expired. But Spectrum Protect is more efficient and smarter. We can set a reclamation threshold, and so Brad might say, well, when there's 55% dead space on those tapes, I want you to take the remaining 45% of the data and move it off to another tape, and then free up that tape to be reused. So this saves Brad and his organization a lot of money because you're managing less tapes. The tapes have a higher utilization of good data. You're not having to keep tapes out there until everything expires off of them. You're not needing as large a libraries or vaults or offsite storage. That all ends up saving the organization money and having a more efficient solution. It also means faster restores because when you're restoring, you're not having to jump over a whole bunch of dead data to get to the valid stuff. So reclamation is just another example of how our Spectrum Protect database, with the way that we track the individual items, really empowers Spectrum Protect to be highly efficient. Another way that Spectrum Protect allows for better use of technology is as technology ages off and Brad wants to upgrade his existing tape drives to the latest and greatest tape drives, or he wants to take data that was originally on tape and now move it out to the cloud, he can do that by simply kicking off a process that says move the data from the old stuff out to the new stuff. And so what this does is it means that Brad isn't stuck keeping old technology around, and he doesn't have to have data sprawled across all different types of technology. He can keep the most recent technology and move the older backups and the older archives over to the new technology. Doesn't have to re-backup or re-archive that stuff. It's simply a behind the scenes process that Spectrum Protect is doing. Another way that we efficiently use the storage pools is with this whole concept of a hierarchy. And depending upon what the customer wants, they may decide, I just want disk in my environment. And other customers will say, no, I want a combination of disk and tape. And I want to be able to, for instance, write out as my files are backing up, I want to send one copy to disk and at the same time send one to tape. Or maybe I want to make a copy later on in the day from my disk pool out to my tape pool. And then maybe I want to migrate my data that was originally sitting on disk after a certain amount of time out to tape or out to less expensive disk. All of that can be set up and managed behind the scenes with server schedules. And of course, Brad can also go in and kick those types of processes off by himself if he were to choose to do that directly from the operations center here. There are wizards built in to do things like migrate, reclaim, or convert. Okay, another thing that we do extremely efficiently with our container storage pools is we do inline dedupe. And so as the data is being written out from the clients to the Spectrum Protect server, before it's written out to our containers, we are deduping it and then optionally compressing it and optionally encrypting it all on the Spectrum Protect server. So if Brad takes a look at this page here, he can see, for instance, that he has a cloud pool defined for the tape server 4. We can see it currently is using 205 gigabyte, and of course it has infinite capacity because it's the cloud. When we hover over the savings button, he can see the amount of data that is being protected as 1.3 terabytes, but it's being reduced after deduplication down to 448 gigabytes. And then after compression, it's being reduced to only 205 gigabytes. So we're only storing 205 gigabytes of the original 1.3 terabytes, giving us a 7-to-1 savings ratio. This is dedupe that's being done on the Spectrum Protect server. There's no additional dedupe appliance needed or compression or anything else. The compression and dedupe in this case is all on the Spectrum Protect server. We do also support, for instance, hardware compression on tapes and disks. If you're using that, we can support that as well. But the savings we're looking at here is the Spectrum Protect built-in inline dedupe and compression. If we go and we hover over another storage pool here, that's on the different server. Here you see we have about a 4-to-1 savings, and you can see the amount of data that was originally backed up versus the dedupe and compression and the ultimate amount of data that we're actually storing. When it comes to the inline dedupe, we can do the dedupe either on the Spectrum Protect server, or if the client wants to dedupe it prior to sending it to the Spectrum Protect server, the client can also do the dedupe. It's utilizing the same hash tables, and then it's sending over just the new chunks. So that's really great if your client is perhaps at a branch and you have limited network in between your Spectrum Protect server and client. Also notice the blue, yellow, and green lines over the capacity used field. This gives Brad an easy way to identify if any of the storage pools or containers are starting to fill up and need his attention. We also have the ability to support cloud containers. These would be both on-premise cloud or off-premise cloud. The difference between an on-premise cloud and an off-premise cloud is who owns the storage. An on-premise cloud, a good example of that is a IBM Cloud Object Storage appliance. Customer owns that, it's in its own IT shop, they have complete control over it. An off-premise cloud would be something like Amazon or Azure or Google, where it's a third-party vendor that we're writing the data out to. And we can support both the on-premise and off-premise clouds. We can convert the old data that might have been sitting in disk storage pools or tape and convert it into your new cloud pools. We do support that convert capability. And as Brad, as his needs change in his environment and he wants to introduce new technologies, he can do that directly from the Operations Center. All he has to do is click this plus storage pool button, and that will walk him through setting up some new storage. I'll just show you some screens here. If I wanted to, for instance, do a Cloud Object Storage cloud, I could easily do that, and I'll click Next. And it'll allow me to choose, is this going to be a container-based storage? And the important thing to know about the container-based storage is these are the types of storage, whether on-premise, off-premise, or directory, that do our inline dedupe and can also support the compression and encryption. Encryption that we can support for these is an AES-256, and the Spectrum Protect server itself is managing all of those keys. So you don't need a third-party key manager or anything else if you choose to encrypt the data before you store it out on the cloud or the directories. Over here you can see our traditional volume-based storage. That would be like disk or tape or copy information. Okay, so let's just pretend we're going to do an on-premise cloud. We would choose on-premise cloud. We would then click next. And here we can choose if we want to do encryption or not on the on-premise cloud. If this were an off-premise cloud, that would be automatically checked because we, of course, highly suggest you encrypt the data before you send it out to a third-party vendor. We support different types of clouds. Here you can see our IBM Cloud Object Storage utilizing an S3 API. We also support OpenStack Swift. And if it's an S3 API, we do have the ability to verify that different vendors' solutions work with Spectrum Protect. So if we do have a on-premise cloud appliance and a third-party vendor wants to verify their solution with Spectrum Protect, we have a couple test cases they run and they send those back to us, and we then verify it, and we put up some information on our web so customers know that we have verified with their product. And then obviously if this was, for instance, a off-premise and it was Azure or Google or Amazon, we would be selecting that for the other screens. Once we select that, you will have a little bit of information that Brad will have pulled when he set up that Cloud Object Storage appliance or when he created the account with Azure. He would have received information like access keys and passwords and bucket names and so forth, as well as URLs where we will be using to write. So we do have good guidance on how to set up those clouds and so forth if you are using third-party vendors and what type of information we'll need to fill out these screens. That's basically all the information that would be needed in order to set up an additional cloud container. When writing out to the cloud containers, the biggest gating factor is going to be the amount of bandwidth available on the network. In order to decouple the backups from the bandwidth available to upload to the cloud, we have introduced something called an Accelerator Cache, and this is unique to Spectrum Protect. The wizard is going to prompt Brad to provide a little bit of directory space on the Spectrum Protect server, and this is going to be a disk directory. And it's going to be used as an accelerator cache. So when the backups are occurring, they will be written first to this accelerator cache. And when they're written, they will be deduped, compressed, and encrypted. Then, as the network is available, we will push that data out to the cloud. And we're not just pushing random bits out. We actually will block the data together in about 1 gigabyte blocks. And what that does is it additionally accelerates the upload to the cloud because the upload works better when it's in larger 1 gig blocks than individual small bits. But this accelerator cache gives us two benefits. One, the backup has been decoupled from the bandwidth available, so it's not having to wait for bandwidth to be available in order to finish the backup. And two, we get better performance because we're pushing out larger blocks of data at one time when the bandwidth does become available. Okay, let's take a look at those clients. Let's go into our client piece. Now, as you've seen already, we support all different types of platforms, not only on our Spectrum Protect server, but also on the clients, and not only different operating systems, but different types of data that we can protecting on those operating systems. When Brad comes and looks at the clients, the first thing he's going to look at perhaps is that at-risk rank that we saw on the overview page. And he can immediately see here in the at-risk category what did not get backed up. First of all, we see some older decommissioned clients that we're no longer doing backups for. Perhaps these people have left the company, or perhaps their machines are no longer even there. We've gotten rid of this particular machine, but we wanted to keep the data around for a while. And then we can see with the at-risk For instance, this finance, it's somehow a backup was scheduled, but there was no contact by the client. So maybe that machine was taken offline, maybe there was a network failure, maybe it was going through maintenance, but Brad will definitely want to follow up and figure out why did that schedule get missed. Here we have a warning on this particular one, and it looked like the backup was scheduled and it ran, but it completed with some different warnings. So perhaps it couldn't back up a particular file because that file was in use or something else. And we'll take a look in a minute here at how he would go about figuring out what exactly happened here. The other thing he'll see on this page is he'll see the different server that these clients belong to and a target server. And this tells him, is this data being replicated over to a disaster recovery server? So if there is a failure and our primary 04 server goes down, what's going to happen is underneath the covers, this client, if he needs to do a restore, is automatically going to be redirected to this active target server, our secondary disaster recovery server. So we can see that this machine and this machine's data is being replicated over. We can see which schedule will be up next for that particular machine and when it was last accessed. One of the things that we see sometimes happening is a particular, especially with archives and regulatory requirements, is we might be asked to prove that a backup or an archive is occurring. And Brad can easily go in and show that, yes, hey, these backups and these archives are actually occurring. So if we go and look at this genome archive machine and drill down into the details here, we can see that it's protecting data and has been running. But if Brad has been asked to prove that particular DNA data was being archived on here, Brad could go out and could try and work with the end user and have them do the restores, and that would be fine. That's one way to get to the data. But we also have a very easy access where Brad just clicks on this link and he can remotely access that data. So this type of access would be totally driven by Brad or another Spectrum Protect admin, kind of like a help desk almost. The end user doesn't have to do the restores or the retrieves. Instead, Brad, the Spectrum Protect admin, is doing them. We are going to do a retrieve. Remember, if you do an archive, we call the opposite of a archive is the retrieve. Backup, the opposite is a restore. In fact, this little interface right here is the same type of interface that the end user would do if they were going to go out and do either an on-demand backup or archive, or they wanted to restore or retrieve their own files. But in this case, Brad himself is going to enter his credentials from Spectrum Protect server. And now the Spectrum Protect server is going and taking a look at all of the data and all the DNA files that were archived for this genome machine. And so, for instance, if we wanted to retrieve that, Brad would simply click on this particular archive date. You can see we have data that was archived on these different dates, so all the different files on DNA that this genome archive was keeping. We can then simply click retrieve. We can choose to either retrieve it to an original location, or in this case, we're going to just put it out in a place where the person who needs to verify that it is retrievable can take a look at. And we're going to go ahead and click retrieve. And now it's going to ask us, do we want to replace them or not replace them if they already existed? So we'll go ahead and place them. Okay, and we can see the different files that are being brought back then. If this was restoring files, we would have the same type of options. We'd be able to either choose one individual file or an entire C drive, for instance, and we can choose, do we want to do a specific date or a point in time, a specific version of the file or point in time to do the restore from. Okay, let's go ahead and take a look at these files since these are on our machine. And here we have our demo 4. And we can see the different logs that are being brought back from there. Okay, so what I just showed you was how an administrator like Brad could go out and could do a retrieve of specific data that he had been given access to, and for instance to prove to different auditors or whomever that we were protecting it. One thing to know is that with the Spectrum Protect, we do have different levels of administrators. Brad, because he is kind of the overall data protection guy, would have the full authority. But for instance, if there was someone who was just managing tape, we have different levels of authority that would just give them different permissions to do different functions. They would still be able to do that all from the same operation center, but they would only have access to the functions their permission level gives them. Okay, so that was an individual file restore. Those were flat files that we just retrieved from that archive, and that was a retrieve done by Brad, a Spectrum Protect administrator, kind of a help desk type of retrieve. Let's go ahead and change users here, and let's take a look at what a SQL administrator, in this case we're going to call him Bob. He's going to be our SQL administrator. When Bob, our SQL administrator, does his daily work, he's usually working inside of this SQL management studio. And so this studio right here would be very familiar to the SQL administrators. And Bob comes in and takes a look and realizes, hey, this demo database for some reason is offline. And he tries to get it back online, can't get it back online, and realizes he needs to do a restore. So Bob can simply go into the tools of his Microsoft Server Management Studio and click on IBM Spectrum Protect, and this will bring him right to our Spectrum Protect SQL interface, Management Console. And from this Management Console, he knows he wants to do a restore, and he wants to do it for that particular database. So he's going to go in to his SQL server, and it will give him the ability to either protect it, and remember, most likely it'll be done, protection will occur on a scheduled basis, but if you wanted to do on demand, that could be done there. Or in this case, to restore and recover a database. And so when he clicks recover, it will bring up the different backups that are available. Remember, Spectrum Protect is interfacing with the SQL backup procedures. So he finds his demo DB4 database. It was a full backup, and he can simply click restore. And we are going to go ahead and do the VS restore. He can see down here that the backup has started and is working. So we'll go ahead and let that run. Okay, so he does have his restore working. While that's working, he might go out and check on the kind of the general overview, which gives him a good insight into what has been protected and what's going on in the environment. So let's take a look at that management here. Here, Bob can see the general activity, the backup and restore activity of his SQL database. Remember, that's all really Bob cares about, is this SQL database. If you look at a lot of large organizations, the IT department has been divided up so that we do have Brad, who is in charge of data protection as a whole, but then we have Bob, who's just looking at SQL and dealing with SQL servers all day. So all Bob really wants to see is, what is my, how many successful backups have I had? Were there any errors on those backups? And if there were, what were they? He can easily see if there were any type of restore errors or backup errors. So this is a nice dashboard that gives Bob an idea about the backup activity and a restore activity. And the important thing is that this isn't tools that Bob is used to. He's used to these MMC interfaces. And so he feels comfortable doing his job. He knows where to go to get it done. He doesn't have to learn a lot about Spectrum Protect. Here we can see our restore SQL restore completed successfully. The other thing that Bob might want to do is to do an on-demand backup of one of his SQL servers, and he can easily do that by just selecting the database instance that he wants to protect, and then he can come over here to the protect field, select that, and then does he want to do a full backup or copy only full, or whatever options are available from SQL. So we're going to go ahead and do a full backup. Once again, he'll see in the task details down here that the backup has started, is working. Now, Spectrum Protect works with a lot of different database and mail applications, including SAP HANA. In fact, with SAP HANA, we are certified, and when it comes to SAP HANA on Power, we're actually one of the only database backup vendors to be certified on that platform. These would be online backups. They don't have to be taken offline in order to do the backups so that they're consistent. Everything is online. And all of the schedules to do this, of course, are happening behind the scenes with Spectrum Protect. But those schedules were set out by the blueprints. So when Brad, our administrator, ran the blueprints, it did generate a schedule to protect the databases. Okay, so that gives you a good idea of what it looks like from an SQL admin's perspective. Okay, so we've seen the retrieve of a flat file. We've seen an SQL backup and retrieve. Let's take a look at what how Spectrum Protect interfaces with the VMware environment. So in this case, I'm switching over to a VMware admin, and this VMware admin's name is Kevin. And Kevin's day is spent inside of the VMware vSphere web client. When Brad set out to install Spectrum Protect, he would have sized it to accommodate VMware backups. And Spectrum Protect is integrated directly with vSphere web client. And we do have a certification from the VMware on our integration. When Kevin comes in and is interested in knowing the status of his backups, he's going to take a look at the monitoring IBM Spectrum Protect. And here he's going to be able to see, gee, what's going on with these different virtual machines? And we can see we have some of the, when the backups occurred for the different VMs, and were they successful, or were there any type of failures for those backups? One of the things Kevin might be asked to do is if a virtual machine went offline and had some type of problem, he would be asked to do a restore of that. Over here we can see we've got a flash VM1, and let's just pretend that for some reason this flash VM1 gone offline and is not being able to be brought up again. In order to do a restore, all Brad has to do is click on the virtual machine, do a right click on that, and then go down to IBM Spectrum Protect and click on Restore. When we look at this restore, it's going to also go out and figure out, well, when did the backups occur for this particular virtual machine? And so we can see here the different availability dates for the different backups, and if those available backups, what time they occurred at. So in this case, let's say Kevin wants to restore back to Sunday before the latest ransomware hit. So he clicks on the 25th, he chooses the 10 o'clock backup, and he clicks Next. He can then choose if he wants to create a new virtual machine or replace the existing one. And Spectrum Protect will give a name if you choose to create a new one. You could also change that. And now he has a couple options on how to do this restore. The first is going to be a traditional restore where the restore is occurring underneath the covers, and once the restore is done, the end user can go in and access it. We also have an instant restore. In this case, once the restore has started, an end user can log on and start accessing data immediately, even if the restore isn't completely finished. And so this is really great in a big disaster scenario where we need to be able to get on and start utilizing the data even if the very large VM hasn't completely restored yet. And finally, we have an instant access. And this would be a way that Kevin could create a temporary virtual machine and go in and kind of test it to make sure, for instance, that the databases were being backed up consistently, or other types of verification on how the machine was being protected. With this option, the VM is not restored to disk. It is simply mounted from the Spectrum Protect server. However, if Kevin decides he does want to restore this, he can utilize vMotion to move it out to an actual disk and restore it completely. So we're going to choose to do a traditional restore of this virtual machine. When the VMware restores go about, they basically follow the same process as when we're provisioning a brand new virtual machine. All of these steps would be very familiar to Kevin. He wants to restore all of the available disks that were in the original configuration for the Flash VM1 machine. And now he's going to decide which data store does he want to do the restore to, and all of these data stores would be familiar to Kevin. He would understand what type of disk they are, and here he can easily see the capacity that's out there and free space. So he's going to go ahead and choose this as his data store to restore the new VM to. He'll choose a data mover to help with that restore. We'll use this Linux data mover. And then he can read pieces before he clicks off the finish. And there we go. Over here on the left-hand side, we can see that this new machine is being restored. Also down below in the tasks, we can see that we have a restore virtual machine running here in the recent taskbar. And this is an environment that Kevin would be very comfortable in and very familiar with. As that restore goes on, I want to talk to you about other things that Kevin can do and can change in this environment if he chooses for Spectrum Protect. When Spectrum Protect was integrated with vSphere, Brad, our Spectrum Protect administrator, would have worked with Kevin to understand, how much data are we talking about? How much data will you be sending to Spectrum Protect? And that would have been built into the blueprint when Brad was designing and sizing the initial Spectrum Protect server. In addition, a schedule would have been created by that blueprint for the VMware backups. And all of this is accessible and easy for Kevin, our VMware admin, to see right here from this IBM Spectrum Protect badge. And if he clicks on that, he can easily see that, oh yeah, here's my connection with the Spectrum Protect server, and here's the schedules that by default are out there. Now, Brad and Kevin may very well decide to define more than one schedule. That's completely up to them. There's flexibility on using more. But here we just have the default schedule that was created by the blueprints. And when we look at all of the virtual machines that are out there, by default, all of those will be protected by that schedule. And when we talked with our different customers using the VMware environment, we found that 95% of the machines use this default schedule, and there's only maybe 5% outliers out there where Kevin needs to go out and adjust the way that they are protected. Perhaps the types of schedules that are run against them, or how often those schedules are run, or how long we're keeping the data. And Kevin can easily adjust that by simply going in here, and the first thing he might want to adjust is the status of those machines. Because remember, when this status right here tells us, have we protected this machine? Was the backup successful? Or is there some type of error occurring that this backup didn't happen last night? And with this risk status, it's kind of like, how much pain tolerance do we have to missing a backup? And are there machines out there that we really don't care if they get backed up or not? Maybe they're test machines, or maybe they're being protected in a different way. And we can see here right off the bat that we have set up different machines that we're ignoring. We're not even worrying about if they back up. And if there were other machines, for instance, these test machines down here, the demo machines, if on a daily basis we didn't even want to have to look at their backup status, if Kevin just didn't want that noise in this visual, he can simply go to the test demo environment. Let's find one. Here's one right here, this TV app demo. He can click on this and he can say, you know what? Just ignore this machine. I don't really care if it backs up or not. Don't give me any warnings about it. Likewise, he could customize it if he wanted. Instead of your default 1-day warning if it didn't back up, he could set it to 12 hours or something else. But because this is a demo machine, we're just going to say ignore it. And that will save that at-risk policy. Now, if he wanted to change the policy or the schedule that's utilized for a specific machine, he can also do that. So for instance, over here, we have an SQL machine that's being protected. And with this SQL machine, there it is, he can also go into the actions. Kevin can say, I want to give this a different data protection policy, and here he can either exclude it completely, he can assign a different schedule, or he can assign a different retention policy. So instead of keeping the extra backups for 30 days, because this is such a large backup with that SQL, he just wants to keep it for 14 days. So he can easily change the retention policy right there, and then click OK. So by default, we will protect all of the virtual machines. And then if we want to make any exclusions, Kevin can easily do that. And all of this occurs because of the tagging that's happening behind the covers. So let's take a look at that tagging. If we go into the summary here for the Tucson Blueprint Data Center, we can see the tags that were assigned when the blueprint set out the default schedules and data movers and things like that. We can see these tags were assigned to this specific data center. Now, all of the virtual machines underneath this data center will by default inherit these tags. But for those 5% of machines that we want to do something different for, those taggings can be changed. So for instance, on this machine right here that we are not backing up, and this would be because it's being backed up by a different application or something, you can see that we've excluded that tag from being inherited. So that's how tagging works. By default, Spectrum Protect has different tags that we utilize. If Kevin is really sophisticated with tagging, he can also create some of his own tags to impact the way that Spectrum Protect does its backups and policies. Over here we can see our Flash restore. This was the Flash machine that we did the restore from, and it looks like it completed successfully. So let's now take a look at how an end user that has an account on one of these virtual machines would go about restoring an individual file. We've seen how you can restore a whole virtual machine, but how about an individual file? I have this VM-Tap2 Aura virtual machine, and I'm going to switch users now. Now I'm going to be an end user. And this end user is going to be myself, Trisha Jiang. So I'm going to log on, and I'm logging on just like this was my desktop. This is just my normal, okay, and here's my normal workstation desktop that I would see. And here I have this important document that I've been working on, and oops, I made a bad change to it. This change really messed it up. And I also saved that file and saved that awful change, and I've now made a mess of this important file. And so as an end user, I want to have the power to simply go out and restore the backup that was created last night of that important file. I don't want to have to call Brad, or I don't want to have to call Kevin to do the restore. All I have to do is click on a link that I've been given by Brad, and that's going to take me to the Spectrum Protect server and allow me to restore my files. So I do need to know my logon credentials, and these are my VM logon credentials. This has nothing to do with the Spectrum Protect. These are just my normal VMware credentials. And remember, this URL was given to me, and I understand that my file is being protected, and I've learned that if I have to restore them, I just click on this link. This is a really great example of how Spectrum Protect can be used as a service offering, where the end user doesn't need to know anything about Spectrum Protect, doesn't have to have a special account on Spectrum Protect, but this end user's files are being protected by Spectrum Protect, and there's an easy way for Trisha, the end user, to go and easily retrieve those files. The nice thing about this is the person who's providing this backup server doesn't have to create any special accounts for all of those end users, for those hundreds to thousands of virtual machines that we might be protecting. And it gives the end user the satisfaction that they can go back and restore files if there's been any type of error, without having to wait around for an administrator to help. So this gives a little tutorial if this is the first time I've done a restore. The first thing I'm going to do is choose which point in time do I want to restore to. I know that last night that I had the latest version of it, it was all good, so I'm going to restore that version of the file. If I had wanted to go back further, I could simply have selected that as well, but I then click Choose Backup, and now it's going out and talking with the Spectrum Protect server to find out which files were protected and the versions of those at that time. When Spectrum Protect did the backup of this VMware environment, it did it using the snapshots with the change block tracking. And so we did the incremental backups of each of these VMs utilizing the CBT change block tracking capability. So even those incremental backups are going to be very small relative to having to do a full backup. So here we have the local C drive of this virtual machine. When Trisha clicks down and looks at those, she knows that her files were under user. So let's go to user. And underneath users, she not only sees her name, but she also sees, for instance, Susan. And she's thinking, oh, I wonder if I can restore Susan's. Well, no. Trisha does not have access to Susan's files, so she can't restore those files. Different permissions. So we're going to go ahead back to the users, and we're going to take a look just at Trisha's files. And here it was on the desktop, so we click on desktop, and there we go, my important document. So we're going to go ahead and restore that. Now when this restores, I have the restore in progress. It's telling me where it's bringing it back to. And if I actually go and look at my desktop, I should be able to see that file coming back here. So here was my original one that I messed up, and I left it out there just in case there was some valid data. And voila, Here is the new version with none of the errors that I introduced. So you can see how simple it is for an end user to restore individual files without needing the help of any administrator. Okay, let's go back to Kevin and back into the vSphere environment. And let's take a look at some of the other things Kevin can do with Spectrum Protect. If Kevin wanted to do an on-demand backup of a virtual machine, he can easily go in and just select the virtual machine. In order to do an on-demand backup, Kevin simply clicks on that, goes into the IBM Spectrum Protect, and clicks Backup. He can choose to do an incremental, or he could choose to do a full backup. Remember, incremental is using the change block tracking, so we're going to go ahead and do incremental. You can then choose the data mover, and the data movers are the pieces that go out there and extract the data from the snapshots and send it to Spectrum Protect server. So we're going to once again use the Linux data mover and then click OK. What Kevin will see is here in the recent task, he'll see that that virtual machine snapshot was created, and now we're actually working to back up the virtual machines. So this is the world that Kevin's comfortable with. He's comfortable with seeing his virtual machines, he's comfortable with the tagging, and he's comfortable seeing the recent tasks that are running in vSphere. If we go back to the Operations Center and look at Brad, let's take a look at how he sees the different backups and archives that are occurring. So for Brad, if he goes into the different servers, and we're looking at our primary server here, tap server 4, and goes into details, Brad has the ability to take a look at the different active tasks and completed tasks. The first thing Brad will probably do is filter that, so he's just looking at client tasks. So we're just going to do the type is client. Oops, client. These filters are really nice because they allow Brad or any of the Spectrum Protect administrators to easily just see the type of information they're looking for. And you can do multiples where you have ands or ors if you had multiple statements you wanted to filter on. So here we go. Here we see the virtual machine backups coming through for that blueprint virtual machine. It's currently in idle wait. You can see that the archive, remember we went out there and did some retrieves, and so it's sitting out there as well. When Brad clicks on this particular task, he'll see all of the messages associated with that task. These messages are kept in the Spectrum Protect activity log, and we keep everything from informational to warnings to errors, and it's kept chronologically. In addition, each message has its own number associated with it. This is critical for a couple reasons. One, because this is a chronological log, it gives us a good idea if something went wrong, we can easily see what was happening before that might have impacted it. And secondly, because of the very specific message numbers, you can easily search on those either in our message guides or out on Google if you want to see what other people have done when they've had that type of message. So here everything's in order, there's no problem with it. If we go and we look at completed tasks, the completed tasks are things that have already been finished, and maybe they're backups, maybe they're restores, or maybe they're daily maintenance that happens on the Spectrum Protect server. When the blueprints ran their scripts to customize Spectrum Protect server, they also put into place maintenance schedules for the daily maintenance that occurs on the Spectrum Protect server. Things like expiring off files that are no longer needed, a schedule for things like backing up our Spectrum Protect database, a schedule for migrating data that might be migrated from a disk out to tape. So all of that behind the scenes schedule are running, and we will see in this completed tasks not only the Spectrum Protect client messages, but also our daily processes that have to do with protecting and keeping the Spectrum Protect server healthy. Brad will also easily be able to identify if there were any problems on these tasks, because here in the completed field we have this big red X or this green, yes, it worked fine. And this is going to tell him, hey, there was some type of problem when this tap server 04 was running its process, or this cloud mover. And this is going to help Brad immediately zone on what he needs to pay attention to. So if he clicks, for instance, on activity that failed, below it he will see all of the messages associated with that task. And this will give him a quick view of, hey, what exactly did happen and why is, what error message is out there. And here we can see there was a schedule file incremental domain for node failed, and it gives a specific return code and everything else. So this schedule had a failure, and now Brad can go out and figure out exactly what happened. For Brad, our Spectrum Protect administrator, being able to look at the active tasks and the completed tasks not only give him a rapid way of ascertaining what is currently occurring on the Spectrum Protect server, but also what has completed, and did it complete successfully? And if not, why not? He can easily get the related error messages with that. Now these error messages, anything like this critical failure right here, will also percolate up into our alerts. And if you remember from the Spectrum Protect overview bar, we had an alert panel, and those alerts are divided kind of into the different areas that impact Spectrum Protect, whether it's tape drives, whether it's something going wrong on a virtual machine, whether it's the Spectrum Protect server itself that's having some type of problem. And the reason that we break this out is we realize that in a large corporation, there's often your IT department is divided up into different users who have different skill sets. In our environment, we had Kevin, who specialized in Vmware, and we had Bob, who specialized in SQL. And so if an error occurs that really should be addressed by Kevin, our VMware admin, we can easily take that message or that warning or that error, and we can assign it to the person who would be best at resolving it. And so, for instance, this one, let's just assign to Kevin, who was our VMware admin. And when the alert is assigned, Kevin will then receive an email telling him, hey, take a look at this, and here's the message number. And once Kevin has gone out and figured out what the problem was, he can then come into the same operations center and close out that alert. So what this does is it helps manage any type of error that's occurring in the whole data protection environment, not just on the Spectrum Protect server, but on the clients, on the networks, on the storage pools, on the tape devices. And it manages this so that proactively we can address the issue, keep track of critical issues, and lifecycle manage them so that once they are completed, we can close them. Now, Spectrum Protect itself will also do lifecycle management here. It will keep track of how many times that message occurred. And once, for instance, if it was a network message and the network then comes up again and those messages aren't occurring anymore, it'll simply drop the severity and that will eventually roll off from the alert tab. Now, these alerts are being driven by the specific error messages. By default, we track the top 100 errors that we saw our customers experiencing and being concerned about. But Brad can also go in and configure specific alerts on specific messages that might pertain to his environment and which he's extremely concerned about. Once again, the alerts help the Spectrum Protect administrators like Brad proactively track and keep up with any issues appearing in the entire data protection environment so that they can quickly resolve them and keep the backups and the restores viable. We also had the concept of the clients. The clients themselves keep error messages out on the production machines that we're protecting. And when we are protecting these machines, if there is some type of failure there, Brad, our administrator, can go and remotely diagnose those errors by simply going into the clients, TAPSRv4. We can see that there was a failure. Brad wants to remotely diagnose why did that fail. Into the details and go into diagnosis. And what's happening here is these error messages, unlike the ones we just looked at, are coming from the Spectrum Protect clients. These are the messages we keep on the Spectrum Protect client that are very specific about the backups and the client issues. When Brad takes a look at this client, once again, remember this is remote, He's going to see the message, and we're going to get recommendations on why that failure occurred. So for instance here, there was some type of configuration problem with and the recommendation is an invalid file system or other backup domain was specified. You can see right up top, in fact, the most relevant message will be highlighted right up top here. And so he can take a look at this message that shows up, and it says, invalid domain name, tap server C, payroll. Oh, Brad knows immediately what happened here. Instead of having 2 L's on payroll, only 1 was entered when this script or whatever kicked off. So that was the problem right there. And then Brad can get in contact and make that fix very rapidly. Okay, so that's taking a look at error messages that might be specific to the clients and how we can log on the clients and how Brad remotely logged in, didn't have to walk over there, didn't have to call up the owner of that production machine to understand what was happening. He could see all of the messages brought into the operations center and remotely diagnose. Another type of piece that Spectrum Protect offers is reports. We can take all of this information that the Operations Center is gathering and we can roll it up into a nice tight report that can be sent out to interested parties. Now the reports, right out of the box, we have this General Operations Report. And this General Operations Report can be set up to go out once a day. And it can be sent to specific interested parties. So that may be additional Spectrum Protect administrators, or it may just be an email address of an individual who wants to understand what's happening in the backup environment. And this report gets sent to that email address. So that CIO or whoever it was doesn't have to come looking for the information. We're delivering it to them. And in a second, I'll show you what that report looks like. Now, Brad can also set up customized reports. He can easily create a customized report to generate information on specific data that he wants to know. And the way that we do that is that Spectrum Protect can collect that data, can get it from the Spectrum Protect database. All of those database tables can be accessed with easy SQL queries. So if Brad is, for instance, interested in seeing the dedupe rates and things like that on the clients and having that information sent out to the interested parties, he could create a customized report for that. So let's go take a look at those reports. Okay, so here I've been keeping the different reports that have been sent to me. If we want to look first at the general report, here we have an executive summary that tells us the backup success rate. It tells us the activity of how much data was sent over the day, and then it breaks it out into applications and virtual machines. It also tells us the number of machines that were protected and if any of them were at risk, and tells us availability of the servers as well as the storage that we're saving it on. This is a very simple overview with a lot of great information that different people in the organization like to have so that they know, hey, what is happening out there? If they want even more information, they can click on this attachment, and this will allow them to drill down, for instance, to, well, what clients did fail? I saw there were 3. Well, here's the 3 that failed. Whoever receives this report does not have to have an account on Spectrum Protect. They don't have to know anything about Spectrum Protect or how to access the Operations Center or anything else. We're delivering this information to their inbox in a nice, simple way that they can understand the high-level overview of what's happening. Let's go back and take a look at the customized report that Brad had created. Here you can see the data that he extracted from the Spectrum Protect server database had to do with the protected megabytes, written megabytes, the dedupe savings, and the compression savings. And so this is over the last 2 weeks, and that's just being summed up in a nice table so that he can see how effective Spectrum Protect is on compressing the data, deduping it, and saving him space so he's not having to continually buy additional storage to store the protected data on. Okay, let's go back into the Operations Center. Okay, so that was reporting. The final thing I want to take a look at is replication. Remember, replication is how your Spectrum Protect server is able to create a offsite copy of all of its data, so that if that Spectrum Protect server is hit by a hardware failure, is hit by ransomware, is hit by a earthquake, the customers who depend on being able to access their backups can still do that by accessing the replicated data on the secondary server. This replication is built into Spectrum Protect. You don't need any special hardware. You don't need a VTL where you understand which blocks and bytes and what's the status of the replication. All of that is invisible. This replication is so simple because it tracks for Brad which data has been replicated, was it successfully replicated, and if there is a failure, the clients will automatically be redirected to this secondary active server. And when I say active, what I mean is that where we're replicating our primary data over to is also a Spectrum Protect server. It may be a Spectrum Protect server that was set aside just to be a disaster recovery server, or it may be a Spectrum Protect server that's also protecting data, but just at a different location. When we do replication, you can have one source server, your primary server, replicate out to an individual target server, or you can have multiple primary servers replicate out to one target server. So if you remember, when Brad set up the two Spectrum Protect servers, one was a medium-sized server and one was a large-sized server. In fact, this is a Windows machine and this is a Linux machine, so they can even be different platforms. It doesn't matter. And one of the nice things with having two different size servers is you might have multiple Spectrum Protect servers here replicating, multiple medium or small servers replicating out to one large server. Another nice thing about these, not only can they be different hardware, remember I said this server is a Windows Spectrum Protect server and this is a Linux Spectrum Protect server, but they can be at different locations. This one might be sitting in San Jose, California, and this might be over in Sacramento, California. As long as they have a network connection in between them, that's all that's needed. And when Brad utilized our blueprints to set up this environment, replication was part of what was set up. Now, not only can we be replicating different types of Spectrum Protect, like a Windows over to a Linux Spectrum Protect server, but maybe this data was sitting out in a directory container or a cloud object storage machine. Doesn't matter. We can replicate that over to the target machine, which might be to tape. So we can replicate different types of storage over to different types of storage on the other Spectrum Protect server. Another thing we can do is maybe this source server has a policy where we are keeping only 3 versions of a file, because it's a small server. But over here, because we have more space, we want to change it to have a dissimilar policy, and now it's going to keep 6 copies of those files. And so a lot of times we see that, for instance, in a back office machine, Spectrum Protect server, which is limited in its space, it might replicate out to a larger Spectrum Protect server, which can maintain more versions of those backups. Replication is really powerful because we can do different operating systems. One Spectrum Protect server could be on Windows, one could be on Linux. You can do to different policies and how much data is being kept. You can do different hardware. You can have it replicate from a disk storage pool over to a tape storage pool. And it's all automated. Spectrum Protect itself is tracking what was replicated over. Now, when we choose what's replicated, you may choose to replicate all of the different clients you're protecting, or you may choose just to replicate, depending on service level agreements, a subset of that. And if you remember when we were looking at the clients, I said, see, this one is replicating, but this one's not. So Brad can decide based upon service level agreements whose data is replicated over or not. We also replicate incrementally. So we only send the changes that occurred last night over to the target server. We don't replicate everything every time. We only are replicating the new data. Also, when we replicate really wisely. If the data has been deduped and compressed on the primary server, and it's going over to a storage on the secondary target server that also supports deduping and compression, we keep that data deduped. We don't uncompress it and undedupe it before we send it over. We just send over the changed little blocks there. So it's very efficient in what it sends over. This is a integrated part of Spectrum Protect. You're not buying any extra services or buying any extra hardware or having to set up any type of hardware replication or software replication to support this. Brad doesn't have to go learn about the VTLs or HADR or anything else to understand what's being replicated. He can see directly in his operations center if replication's working and exactly which files have been replicated over and are protected. The end user benefits because if there is a failure on their primary server, they are automatically redirected to the secondary server to do their restores. If the primary server is out for longer than a few hours, you could also set it up so they do their backups to the secondary server. So with the replication, that is how we would do disaster recovery. Now we can also protect the Spectrum Protect servers by doing database backups and copy storage pools where we take tapes off site. So we have multiple ways to protect the Spectrum Protect server, but this replication is highly effective because it is an active replication that's incrementally replicating over those deduped and compressed changes to the secondary server. So what I've demonstrated here, I've shown you how Spectrum Protect aligns to the data protection needs of businesses. And it does this by offering a breadth and depth with efficient, powerful data protection options built in. And those are options that are going to do things like inline dedupe, compression, the ability to do incremental forevers. Those types of features in the end are going to save the customer a lot of money because we're only backing up the needed information. We're not backing up repetitive information. We're not taking up extra resources. And therefore, you're going to have a smaller footprint for your data protection environment that's going to cost you less money. But this Spectrum Protect is highly efficient and highly effective also for the end user because when they're utilizing it, the interfaces have been built to allow them to be able to do their jobs in the applications and in the interfaces they're comfortable with. So for instance, Brad here was first of all able to rapidly install and configure the Spectrum Protect servers using our prescriptive reference architecture blueprints. And then once they were installed, he can monitor all those different clients that are being protected and the Spectrum Protect servers from a single pane of glass, this operations center. Now this operations center not only gives them the ability to monitor what's going on, but it gives them the ability to drill down and troubleshoot. It gives him the ability to kick off wizards that are going to help him grow the Spectrum Protect environment as his data protection needs change. And it gives him the ability to customize the data protection schedules and policies to meet his end user's needs. We then have the different types of data that we're protecting, whether it's application data, virtual machines, or system data. And Spectrum Protect has also been optimized to give those users an efficient way of interfacing with Spectrum Protect. So for instance, we saw Kevin, our VMware admin, was able to use his vSphere web client to do the protection, the restores, the backups, as well as being able to monitor the status of his different VM machines. Likewise, Bob, our SQL admin, was able to use the MMC interfaces to do backup and restore of his SQL instances in a methodology that met the needs laid out by the database vendors to do online backups. So the end users are likewise empowered through the self-service capabilities like file level restores, and by being able to go out and restore their data without having to wait around for Brad or other people to help them. And this opens up the ability for service providers as well as large corporations not only to be protecting the databases and the big entities, but also the end users' information. So in summary, Spectrum Protect provides enterprise-class data protection that meets the business and the user's needs. Let's switch gears now and take a look at IBM Spectrum Copy Data Management. Stacy, our storage admin, has been seeing growing interest in different people in the IT department wanting to use hardware-based snapshots for different purposes, like DevOps, data protection, copy management. But this has caused two issues. The first is, with all these snapshots being created, they're often not cleaned up. And so we ended up with a lot of wasted space. So Stacy needs a way to lifecycle manage the snapshots that are being created and clean them up when they're no longer needed. Second, Stacy wants to be able to govern who uses what type of hardware, creates how many snapshots, and how long those snapshots are being kept for. So she wants to be able to implement service level agreements. With copy data management, Stacy can make copies available to the data consumers when and where they need them. So let's go ahead and take a look at IBM Spectrum Copy Data Management. She will be installing a small VMware image into the environment, so she doesn't have to introduce any new appliances or anything else. It's a simple in-place install, which will be up and running in about 15 minutes. Once the install is complete, she'll want to go out and configure that environment to include the different hardware that's in her environment, the different applications, and the different sites. Maybe she has hardware that's sitting in New York. Maybe she has different hardware and different applications that are sitting in Silicon Valley. So here she'll go to the sites and providers on configure. She can go into sites, and as you can see, she's already set up her Silicon Valley, Berlin, and New York sites. And then she'll go into the provider and pick out the different hardware and the different applications that they're utilizing in this environment. And here we can see, for instance, that she's already defined an application server for that SQL database that Bob was the administrator of. And we can also see she has already defined and connected with the storage here. This is a storewise storage. So in this storage right here, the general information we can see is an IBM storewise 3700. CDM, once it has permissions, will go out and find all the volumes associated with that storage as well. In the same manner, we've also defined our VMware environment, and that was the VMware environment you saw Kevin running. And we can expand that and see that it also sees all the different virtual machines and everything underneath that particular VMware. Now, in order to define these different pieces to the copy data management, Stacy will have to have provided some access to that. And that access would include things like the password and a user ID on the SQL or on the VMware or on the Storewise. And depending on what type of application or hardware it is, it'll need different permissions to be able to access that. The nice thing about that is that it's agentless. She doesn't have to go and install an agent on the Storewise or an agent in the VMware environment. She just needs to have the correct user capabilities for the different pieces. Now, once she's gone through and created these different sites, she's identified the different hardware applications and in those sites, and she's provided the correct credentials to access that, she'll also want to set up some service level agreements. And these service level agreements will determine things like which type of hardware can be used to create snapshots, how often can those snapshots be created, and how long am I going to retain each of those snapshots? And this becomes really important because now Stacy can control who's using which resources, how many snapshots they're creating, and automatically having those snapshots expire and be deleted once they pass their service level agreement policy. So Stacy has created 3 different policies out here. As you can see, she's called them gold, silver, and bronze. And she can easily create new policies just by clicking on the new there. She has done most of the setup, and that might have just taken an hour or so. It's not very complicated, easy wizards to walk her through those different steps. The next thing she'll want to do is create individual jobs. The jobs are what actually create the snapshots and can do them on a creation on a regular basis, as you saw with the service level agreements. Let's go ahead and show how simple it is to create a job. We'll go ahead and click new, and we're going to do a backup job. Now, what is this backup? This is just creating a new snapshot, and this snapshot can be used for many purposes. It could be used to do a restore. It could be used to create a snapshot that then would be offloaded into Spectrum Protect via our data protection pieces. Or it could be used to clone and create some type of new DevOps in a different location. But we're going to create the job. We'll call it the monitoring VM. We're going to use our default environment here. And I'm going to go out. You can see we have the Tucson blueprints. I'm going to give this job a gold level so that they can create every hour. Okay, and instead of backing up the entire data center, I just want to back up this particular VM. Now, the reason that I might choose to use CDM to do the creation of a snapshot of an individual virtual machine versus using the built-in vSphere web client capability is vSphere web client is using the VADP technology, whereas when we're doing these snapshots, these are hardware snapshots, so they'd be a lot faster than the speeds and feeds that Kevin would see using VADP. So in our case, we're just going to do this individual VM. I'm going to go ahead and create that job. And now that that job is out here, if I want to kick it off on demand, I don't want to wait for it to run on a scheduled basis, I can simply click Start. And since this is a single on-demand kickoff, I can choose to change the policy, whereas if I just waited for the job to run, then it would utilize the service level agreement that I originally signed to it. But I still want to use gold, so I say OK. And then down here in the activity, I can see that that snapshot is being created and it's running. So you can see how simple it was for Stacy to create jobs, and a lot of these jobs will just run on a regular basis behind the scenes as depending upon what their service level agreement was set up to. But I also showed you how you could create a job that you could kick off on demand. Okay, well, while that's running, I'm also going to show you how we can do the restores of this. In order to do the restore, I would also want to create a job. So I will choose New, and this time it's going to be a restore job. Now it says restore, and this could be used to restore a virtual machine from an individual snapshot, or it might be used to clone snapshots at a different location for DevOps or anything else. Just like with the backups, you may have it so that the cloning occurs on a scheduled basis, or it may just be a one-off. We're going to choose to do an instant VM restore. For my source, I'm going to choose the machines out here that I know have backed up. And in this case, there's that monitoring VM. I'm then going to choose the copy, which is default, and I'm going to choose the destination. Now with this destination, this is where if you wanted, for instance, to send it to a different location or different hardware, this is where it would be really powerful to be able to choose an alternative location. In our small little test environment here, I'm just going to restore it back to our original location. So we'll go ahead and create that job. Okay, so out here it's sitting as a long-term running job, but I'm going to kick it off on demand so you can see it running. Start. Okay, and I'm going to put this in test mode. You do have different modes you can do the restores with. And click OK. I can see the activity running below, so we have started the restore. And Stacy will be able to monitor that directly from here and see it running. It looks like it's about 47% finished, so we'll go ahead and let that finish restoring before we see it over in the web client. What I just showed you was for VMware. We can also do the same for SQL. When we create these can be online consistent backups of that SQL environment. So we do have a lot of power to make sure that if we are creating a snapshot, it is consistent. What I'm showing you is Stacy kicking off these jobs, but part of the power of CDM is that she can give Kevin or Bob specific abilities to do these jobs, and when they create them and when they're run, that's only being done on the hardware for the number of versions that their service level agreement provides. Okay, let's check that web client, and there we go. Now we can see that the restore has gone ahead and finished over here. Okay, so in summary, copy data management is a really powerful tool in the fact that it gives your storage administrator the ability to install a very small VMware in-place installation, don't have to install another appliance or anything else, and this is going to manage your life cycle of the snapshots, and it's going to determine of all the different pieces in your environment who has access to which type of storage and for how many snapshots, and after that policy has reached its limit, the older snapshots will automatically expire off. So you do have lifecycle management built in. Thank you very much.